address the gathering. Kasundi, the virtual floor is yours.
Thank you, Marka, and good evening, everyone. Ladies and gentlemen, esteemed guest speaker, and honored participants. A very warm welcome to each and every one of you. It is with great pleasure and enthusiasm to extend a heartfelt welcome to this special gathering. Today marks a significant moment, a convergence of minds, ideas, and shared aspirations. Whether you are here as distinguished guests, participants, or friends, your presence adds immense value to this occasion. First of all, I would like to take this opportunity to warmly welcome our honored guest speaker, Dr. Vishaka Basnayaka, lecturer at SLTC Research University, who is the keynote speaker for today's session. Your expertise will undoubtedly enrich the minds of all participants. And to all the participants, your presence here today is what makes this event come to life. Your enthusiasm, passion, and commitment to this session and competition are the driving forces behind the success of InspiHER V2.0. Let today be a day of inspiration, learning, and meaningful connections. Let us engage in open dialogue, embrace different viewpoints, and sow the seeds of collaboration that will bear fruit long into the future. Once again, a warm welcome to everyone. May our time together be filled with a fruitful discussion. Thank you. Over to you, Indika.
Thank you, Kasundi, for the warm welcome. Today, we embark on a journey to encourage and support female undergraduates and also the young generation in their pursuits of success and professional growth. Without further ado, let's move forward with our agenda. Today is the second day of our MATLAB workshop series. This session is based on the topic Basics of MATLAB. Moving on with the events proceeding, we have our esteemed guest speaker to conduct the session. Lecturer at the Department of Telecommunication, SLTC Research University, Dr. Vishaka Basnayaka. Dr. Vishaka, the virtual stage is yours.
Okay. Good evening, everyone. I hope you can hear me. So
yes, madam, you're audible now.
First of all, I would like to thank you for inviting me here today. This workshop I would like to conduct the first part of the workshop today, and the second part I will do, I think, after tomorrow. So so I have a question to ask first and foremost from you. The question I have is, do you have MATLAB installed in your computers? So I just want to know, like, whether you have MATLAB versions installed in your computers, and if you don't, then I would like to provide you some, guidance in installing the MATLAB software. So as for the first part of this session, I think I will explain to you about how to install MATLAB in your computer. So actually, most of the time it's a little bit difficult to obtain the latest version of licensed version of MATLAB installed in your computer without having some, university affiliation. So in most cases, like if you are a student of some university which is having the MATLAB license, you can install it very easily without paying for the license. Otherwise, as a individual, you need to pay for it. So alternative solutions are there. So there are some links in the websites in the web that you can have to install the software, right? So if you're having MATLAB installed in your computer, it's fine. Otherwise, I think I will give you a installation link that is available in the internet, basically, to download the software and use it as a as a version in your computer, but note that it is not the licensed version. So you would have to follow certain steps to get it installed. So so I think I will give that link to you first. So if you don't have MATLAB, you can use that to install that software in your computer. Right. So I think this is not the most licensed version, but I believe this is going to be some option for you. If you are going to, if you need the latest version of MATLAB installed in your computer. So I actually tried to install this even recently and it worked. So you can get maybe 2023 version from this link. Otherwise, I think if you're a student at SLTC, you can ask for the MATLAB version available at SLTC. However, of course, it's, I think, 2015 version. So 2015 version is kind of okay, but it has lesser functions. So if you can obtain the most recent version of MATLAB, I think it would be more convenient for you when you're trying to do some computational tasks. So this link you can use to download the MATLAB. So in there, actually, when you're installing, you need to follow the README text that you get. So basically, you just need to follow the instructions that are given in the README text and get the necessary folders installed in that certain manner. It includes the installation keys and the license files that you need in the installation. So you don't have to, you don't need any other information. All the information are given in the README text. So you can follow that certain steps. And if you fail to do the installation, you can let me know. I will help you in that process. Currently, I think I will not be, spending, time on the installation part in this session. But if you face some problems, you can just email me or you can send me the error, and then I will help you. However, it's not that difficult task. You can follow the README text. If you fail some problems, I will assist you in that regard. So let's start with the MATLAB introduction, and in here I will be, going with the introduction first about MATLAB, and we will discuss about how MATLAB interface looks like, and after that we will have some understanding about the different functions that are available in the MATLAB and the different commands that we can use to access those functions. Apart from that, we will also learn how to write scripts and how to organize our scripts in the MATLAB in the MATLAB. So we will learn how to organize a certain code and readable code in the MATLAB. Apart from that, we will also learn about the basic if-else conditions, while loops, similar structures that we can use to define a certain algorithm in the MATLAB. Also, we will learn about plotting, how we can do plots, how we can draw plots using MATLAB. So we'll learn about 2D plots, 3D plots. Apart from that, we will also learn about sample simulations and how we can do some simulations called as Monte Carlo simulations. So if you, I don't know whether you're familiar with it, but Monte Carlo simulations is something that is widely used in numerical simulations when you're doing simulations in, for example, in research. So apart from that, we will learn about the example scripts that can be, and I mean, that can be written in MATLAB, and then we will see how we can see the output of the code. Apart from that, at the end of the, today's session, we will learn about MATLAB Simulink, how we can do simulations in the MATLAB Simulink environment. Apart from, after learning MATLAB Simulink, we will learn about how we can compare the performance of Simulink and then performance of the code-based simulation. Also, at the end of today's session, I hope to give a small quiz. So I invite you to be, present in the lecture or in the session so that you can face the quiz in a successful manner. So I just also want to ask you one thing. Have you formed into groups? Right? Have you formed into groups within yourself for this program? So if you have formed into groups, you can let me know as yes, or you can put your hands up in this meeting. If you have formed into a group and if you have a certain group that you belong into. Okay, I think one student has raised hands. Okay. Okay, so if you have a group, it's good. Do you have a group name, a certain ID that can uniquely identify your group? Okay. If you have a group, I think I have some idea now that you have a certain group within which you work in, which is good, because at the end of today's session, I will give a small quiz, and then you can participate in that quiz as a group if you want, or else you can individually participate, and then you can contribute your mark to the group. So what I mean is that since you're at home and you're joining online, maybe it's better that you individually participate to the quiz. And then at the end of that quiz, I will allocate the mark of your mark to your respective group. So it's like that. So since you have a group, I will allocate marks like that. I hope it's fine with you. And if you have any questions, you can let me know in the chat, or you can speak up at any time, and we will. So I would like to resolve your problems. So I think we will start now, and I will share my screen, and I will explain about the introduction or the introduction. Introductory facts regarding MATLAB. So. Okay, so I will use this whiteboard to make notes. I will share that note with you as a link, and then you can refer to that later as well if you want. So, the first thing that we can discuss about MATLAB is that. So I think my handwriting, I would like you to just excuse my handwriting sometimes, because maybe it's not that okay, but I would like to give some briefing about the MATLAB and what is MATLAB. So MATLAB stands for Matrix Laboratory. Matrix Laboratory. So basically, MATLAB works with vectors and matrices. So you can say basically matrices. So it's designed to work with matrices. So designed to work with matrices. So whatever you define in here in the MATLAB environment, it will basically be a matrix. So you are basically defining matrices when you're defining some variable, when you're defining some integer, any kind of a data you are defining, it will actually be a matrix in the MATLAB environment. So that is why this MATLAB software is named as Matrix Laboratory as well. So it is actually doing work mainly with matrices. So so what is the importance of working with matrices, you will ask. So when we are having to deal with large arrays or large data sets, right? Sometimes, you can easily, work with these kind of large data sets when they are in the matrix form, right? Easily, do the computation using matrices. We can do computations with lesser steps, you would say, and lesser delay when we are considering the data sets as matrices. So we convert these arrays or lists, we would say, like list of data. If we have some list of data, let's say 1, 2, 3, 4, some kind of a list, right? We have a list of data. We can convert that list into a vector or a matrix. So if we have a array or a list, we can convert that into a vector. If we have a data set with multiple rows and multiple columns, we can convert that data into a matrix. So we can have data sets that has multiple rows and multiple columns. So for the moment, let's say that that matrix is like an integer matrix. So that matrix is the integer matrix, or it's the data set that contains basically integers. We can define that a data set as a matrix of data, or matrix of data. So once we have defined that matrix of data, then we can easily manipulate the values of this matrix. And then we can do multiplications, we can do additions, we can do subtraction, division. Likewise, we can do multiple mathematical functions on top of this matrix that we have defined. So sometimes the data set that we collect might not have only integers. We might have to filter only integers from that data set. And then we would have to create another new matrix. Anyway, like if you can create a matrix, then after that you can easily do the computation on top of the matrix. So anyway, so once you have these large amounts of large arrays or large data sets with a large number of data, it's easy to convert and consider those data as matrices. We can easily manipulate them as matrices. And when we compare with other programming languages, those languages do not sometimes have this facility. Sometimes they are taking more time to compute these large data sets when compared with the MATLAB. Sometimes with MATLAB, you can do the computation within seconds because it has this matrix-based environment to do the computation. But in other languages, sometimes you define it as a list, not as a vector. And you define as a data set, not as a matrix. In that case, sometimes that computation takes more time to finish. Right? So Right? So one of the main advantage of MATLAB is basically that it deals with vectors and matrices. It deals with vectors and matrices. So there are multiple applications of MATLAB. So MATLAB is used in multiple domains. One of the application areas is, we can say, communication systems. So communication systems, in communication systems, when you're dealing with, transmission of data and then reception of data, you will model the transmission and reception using MATLAB. And you can model the different effects of the channel conditions in the communication using MATLAB. So basically in wireless communication, telecommunication, you are using MATLAB software. And you can accurately observe the effect of the communication on the transmission, right? So, I mean, you can accurately model the communication and you can accurately see the transfer of information from the transmission side to the reception side. And you can, you can do research and you can study a certain scenario using the simulation that you have created. Right. So, I mean, just explaining a scenario where you're transmitting data from, let's say, from a certain mobile phone to a certain base station. And the base station could be in a certain faraway location. Once you're sending the data, you will be sending some, stream of data, and it will go in the form of a wave. So anyway, once you're sending a certain stream of bits and ones and zeros, let's say, you're sending a certain ones and zeros. However, like due to the effects of the channel, certain signal, the original signal that was transmitted will get impacted by the noise and other factors such as interference. So noise, interference, those could impact the original data that you're transmitting from the mobile device. At the base station, you can observe a certain data stream, and that data stream sometimes might have some error when you're compared with the original data. So it can be consisting of a certain stream of data which is not exactly same to the original data, but a little bit different. So what we are doing in this MATLAB simulation is that there are many metrics that you can consider. One metric could be finding the error rate or the bit error rate of the communication. So you can find the bit error rate from the simulation, and you can find other variables also about the communication. Right, bit error rate you can find. Then you can find the communication capacity or the communication rate, communication data rate. So, data rate of the communication you can find. And other metrics also you can define for the system, such as outage probability, and so on. So you can define different performance metrics for the communication system. And these performance metrics can also be defined in the MATLAB environment. And then you can use the MATLAB environment to measure the bit error rate, data rate, outage probability. Likewise, MATLAB can be used to measure these metrics. Right. Apart from that, so likewise, you can develop algorithms in the MATLAB environment, and you can test the algorithms under different scenarios using MATLAB. So another essential thing regarding, another application that we can use MATLAB for is signal processing. So signal processing is another application in which you can process the signal and then you can obtain the information, useful information from the signals. So, so this includes processes such as filtering, right? Filtering and obtaining data which has lesser noise included in them, and then using that data to make predictions regarding the original data. So you can use different, processes under signal processing. You can do filtering, you can do estimation of the data, and you can do optimization. So these are all like mathematical procedures that are used in signal processing, and these procedures can be implemented in the MATLAB environment. Also, MATLAB is widely used in the dynamic control systems. We call this as basically something used in the robotics, you would say. So in robotics and industrial automation systems, you use dynamic control systems, and you define systems, and you define the input output of the system, and you define the transfer function of the system. So you can define the input output of a system using a matrix, and the transfer function of the system using another matrix. So if you say a dynamic control system that consists of input data, input signals, x1, x2, and then that system will have outputs of y1, y2. And the transfer function of the system will be defined using this matrix. So for dynamic control system modeling, MATLAB can be used heavily, and then it will be easy platform to define these kind of systems, mainly because these systems are already defined as vectors and matrices. So because MATLAB is already built for dealing with matrices, then you can easily define these systems easily in the MATLAB. Right? So I believe that in the previous sessions you have learned about Python. So Python also is a language that can be used simultaneously with MATLAB. Python also has commands that does the same operations that MATLAB is doing. There are different commands that can be used for such functions to implement such functions. However, like MATLAB shows the raw features or raw behavior of the data, or it shows how the data is stored as a matrix in the software. So we will see about all that. So now we will inspect about those features of the MATLAB. So I believe you can see my screen. So I will explain some things on this whiteboard. Then I will explain how some MATLAB functions are working in this interface. So basically, MATLAB interface, once you consider the MATLAB interface, it consists of mainly three parts. And in addition, we have the toolbar on top. So in the user interface, basically you have this directory where the current folder is shown. So you can see multiple MATLAB files. If there are MATLAB files, you can see them in this current folder section. So these files are actually located in the path that is specified in this directory, which is in this place, right? In this path, this small strip of a small white strip, you can see we have defined a certain path. So the files that are available in that path are given in this current folder section. Apart from that, like in the bottom to that section, we have the workspace, and the workspace is defining all the variables that we have defined in the system so far. So all the variables and their values are given in here, right? So once we write a code, we will be able to see the values of the we will be able to see the values of the variables inside this. We will be able to access the variables using the workspace. Right? So we will see once we have typed a certain code, we can see the variables appearing in here. Right? And this entire section is known as the command window. So the command window is used to run different codes or different commands individually, line by line. So if you want to see the effect of a certain code line by line, you can see the effect in the command window. Right? So for that we can use the command window. So the workspace can be used to store the variables, their names, their sizes, and their values. So this workspace contains all the information regarding the variable, its name, its size, and its value. Once you double click on the variable type, you will be able to see their values. And the current folder in which you are working will be given in here, and all the files included in that current folder will be displayed there. So if you are, we will get into running the codes that we have already. But before that, we will go into the command window and how we can use the command window. Right. So, as I said before, MATLAB is a user interface that allows us to, it's a software that allows us to define vectors and matrices. Right. So basically, you can define matrices. You can define vectors using the software. Then you can see the output as well in the command window. So basically, if you want to define a certain vector, you can define it as, if you want to define a vector as A equals 1, 2, 3, 4, 5, you can define it as like this. So this is a row vector. If you want to give a column vector, and you can actually give the elements, and you can put a semicolon at the end of each element. So you give a semicolon at the end of each element, you will be able to see the column vector. And for the last element, you don't need to give a semicolon. However, now if you give a semicolon to each of the elements, you will be able to obtain a column vector. Right? So this is how the rows and columns can be defined in the MATLAB. Right? So if you want to give a matrix, you can also define a matrix using basically both these characteristics. Let's say I want to define a matrix, then I will say that I want to define a matrix which is having 2 rows and 3 columns. So if I define it, I will be defining it as like this. So I will be having a matrix which is having 2 rows and 3 columns. Right? So the columns are defined by the semicolon. So at the end of the first row, we need to define the colon. So that is regarding defining vectors and matrices. Right? So now we will see how we can do special functions on these vectors and matrices. And so if you want to find the transpose of a certain matrix or vector, you can define that using single quotation mark. And so if I want to get the transpose of a certain matrix, if I want to get the transpose of C, then I will use C dash then I will get the transpose of that matrix, right? So transpose of this matrix I have obtained in here, right? So you can do that by using C and single quotation marks. C quotation mark, right? So apart from that, there are other special matrices that are defined for MATLAB. So one matrix is the identity matrix, right? So identity matrix is one of the special matrices that you learn with mathematics, right? So identity matrix is a matrix that has ones in the diagonal and zeros in the other elements of the matrix. So if you want to define identity matrix, you have to use a command called I, right? Command code I, and inside here you can define the size of the identity matrix, right? So you must have learned in mathematics that identity matrix is a square matrix, right? So it will always have same dimensions both in the horizontal way and in the vertical way. So if you define the identity matrix 3 by 3 identity matrix, then you have to define that using the command I inside brackets 3. So then you will obtain something like this, right? So I is the command you use to obtain an identity matrix. And then so if I want to clear this command window, now I have gone through some commands in here, right? And sometimes I don't want all this information, right? So what is the command that I can use to clear all this information? Do you know about that command? Next step, so I have this 3 layers. You can use CLC, right? CLC, and it will clear the command window data, and you can get a clear window. So, so I was talking about the identity matrix. I will repeat that again. Right? Then, however, like again, I will also anyway, I will define it again. I will define it again as I inside brackets 3. Also, you can notice that once we define different variables, all those variables that we have defined, which were A, C, and D, are stored in here, right? A, C, D, transpose C, those are stored in here, right, in the workspace. And you can see the values of the variables by double clicking on the certain variable. Then you can see the elements. Right? So you can see the values of each of the variables that by double clicking on the variable in the workspace. Right? So then transpose C, you can see as the transpose of this metric that we have defined. So you must be able to observe that all these variable values are given like in Excel sheet, right? This is similar to something like Excel sheet, and it's very easy to work with these data once they are in that format, right? And then so whenever we want to inspect some variable, you can inspect through this workspace, and then you can inspect the values of these variables using this workspace and in this manner, in this format. So up to now we have discussed about the identity matrix, and now we will discuss about how to create a unity matrix. The unity matrix is another special matrix that we learn about, And unity matrix is something that we know as the matrix that has ones in all its elements. So it is defined as ones. And unity matrix is also, unity matrix can be defined in different manner. So we can define it as either square matrix and as well as any dimension matrix. So once inside brackets 4 gives us a 4 by 4 square matrix, and then once 1 comma 4 gives us a vector or a row which has 1 row and 4 columns. So basically it's a row, and we can obtain this by defining the dimensions correctly inside the ones function. Right? So you can create any type of any matrix with any kind of a size using the ones command. So if you want other variable which has matrix, which has a size of 2 by 3, you can create that using ones inside brackets 2 by 3. You will obtain unity matrices of any size by using ones and by defining the number of rows and number of columns inside the bracket. Okay, so do you have any questions up to this point?
So we can easily share this if we cancel, because we have this number of context in this then after I increase the context in this share knowledge base, then we can share.
Okay, moving ahead, I will define how we can get a completely zeros metric that we can do similar to ones matrix. And in here, you can define a zeros matrix using zeros function. Right? So you can define that in any format that you prefer by giving the dimensions of the specific matrix. So the specific matrix dimensions you need to give inside the bracket. Right? So that is how we can define certain special matrices. And you can notice that once you are defining the matrices, once you are defining the certain variables, you can see that there's update going on here in the workspace. And like if you observe the different variables available in the workspace, you can see that the values of the variable will be updated to the most recent value. Right? So recent value of H is this matrix with 2 rows and 3 columns. And that value is given in here. Right? So if you can remember, we gave this value as the H when we first defined H. We first defined H as zeros matrix, which has 3 by 3 columns. Right? 3 by 3 dimensions. So in that case, the H matrix had this dimension. However, now since we have defined H as 2 by 3 metric, then the value for dimensions of the H has updated as 2 by 3 metrics in the workspace. So note that only the latest value that we define for the variable is stored in the workspace as the value of that certain variable. Okay, so that is something that you might have to remember. Basically, because when you are defining a certain variable and then you are changing the value of the variable multiple times, then only the last value that you saved for that value for that variable is stored as the final value of that variable. Right? The last value you store for that variable the last value you give for that variable is the value that is stored in the workspace. The previous values will be erased and that value will be replaced by the recent value. So another important matrix type that we want to generate using MATLAB is the random matrix. So random matrix can be generated using a function called rand. In here you can define any random matrix that you prefer. So if you want a 3 by 3 matrix, you can define it as 3 basically, and you will get 3 by 3 random matrix. One thing you can notice is that the values of all these elements are below or between 0 and 1, right? So the values of these elements are between 0 and 1, right? So if you want to get a value which is between another range, you will have to multiply this matrix by a certain other number and then obtain the range that you want. So with the default rand function, we get this. We get these values for the elements. Right, the values will be basically between 0 and 1. Right. So similar to the previous cases, right, you can define different matrices, with different dimensions. So different dimensions can be defined inside the variable, inside this rand function, and inside the brackets you can define the dimensions of the matrix. So if the dimensions correspond to 2 rows and 3 columns, you can obtain a matrix like this. And if you want to, if you want to run this command again, right, you can see that these matrices are different, right? That is also something that you might notice, and that is an important fact to notice in the MATLAB. So as of now, once we are calling the rand function, another time a new set of numbers are generated for this y value. A new set of values are generated, right? So if I run this rand function again, another new set of values are generated, right? You must be able to, I think, observe that the values that we generate here are not equal to the values that we generated earlier, right? So that is due to something something related to this rand function. We will learn about that as well. So that is something that we need to know in order to control the output that we can obtain from this rand function. Right? If at some point we want to control the random values that are generated from this rand function, we need to define something for this rand function, and we need to define a certain seed value for the rand function. Right? So we will define that in later section of today's session. So for the moment, you can just keep in the mind that the rand function will generate new or different random numbers at each different iteration that we call that function. So I will clear the space. So CLC is a command that I use to clear the command window. So another thing is that if I want to obtain previous commands, can basically go to this command window and press the top arrow in the keyboard. Then using the top arrow, you can access the previous commands that you have given in the command window, right? So you can access the previous commands that you have defined in the command window using the upward arrow in the keyboard. Right? So in the keyboard, you can just click the upward arrow. You can access the previous commands easily. You don't have to type them again. Right. So, right.
Here actually,
Right. So I think anyway, I think I will discuss about this rand function here itself. I think mainly because it's going to be easy for me to explain it here rather than somewhere else. So I will now I will show you that this brings some set of values for the random matrix. Okay. So if I give a matrix like this, if I generate a matrix like this with 2 rows and 3 columns, I will obtain a matrix like this. So if I want to keep this value same all the time, right, without generating new or different random values, right, I need to define something called the seed value. So something called the seed value I need to define. If I will define the seed value as 0. Right?
Excuse me,
And
madam.
if I want to generate the
Excuse me,
same
madam.
or same random matrix each and every time, right, I need to define this kind of a seed value. Right? Then after that I can define this rand matrix.
Excuse me, madam.
Yes.
Madam, I think there is a background voice from your end. So, if you can, could you please consider about it?
Yeah. So, are you hearing some noise currently?
Yeah, like some tutoring or something like that.
Sorry?
Some tutoring voice or something like that we can hear from your background.
Okay. Okay. Now it's okay, right?
Yeah, madam.
Okay.
Thank
Okay.
you.
I will try to. Yes. I hope it is okay. Yes. So now I think I will generate the random matrix 2 by 3. Right? Now you can see this is the random matrix I have. Right? And if I give the same command again, I should be able to get the same matrix again. Right? So, right? So earlier, when I did not define the seed value, when I just define the random function and define a matrix using the random function, I was getting different values for the elements in the matrix. Right? I was getting different values for these elements. Right? However, now if I fix the random, value generation seed value, then I can fix the random numbers that are generated as the elements in here. I can get the same elements each and every time I call this command, right? So whatever the number of times I call the same command, I will get the same value for the matrix. However, if I do it without defining the seed value, if I remove this, if I call that function without a seed value definition, then you can see that the numbers that are generated here are different to the numbers that I got earlier. Right? And each time I call this random function, I will get a new set of data as the element values. Right? As the elements, I will get different values for this element. Right? You will get different values each and every time. Right? So in order to control that, you can use that command that I mentioned before, which is basically defining the seed value and then defining that seed value inside this function, which we define as RNG, right? RNG, and inside that we define the seed value, and that will generate random numbers based on the seed value. right? So, so once we call this random function, each and every time that random function generates that random set of random numbers for this matrix, they will consider this seed value, and only from that seed value the random numbers will be generated. Based on that seed value only, these random numbers will be generated. Otherwise, if you don't specify the seed value will be taken by the software itself, and the seed value can vary from one iteration to another iteration. So the seed value, if the seed value is different, then the random value that is generated is also different. Apart from that, like this seed value is the one that defines how the random numbers are generated for that certain instance. So what I mean is that once you are generating some random numbers, that random numbers are also generated using certain algorithm in the MATLAB software, right? Random numbers are not just random numbers that the computer takes into account. Computer does not know how to generate a random number. Computer follows a certain algorithm to generate the random numbers. And the computer takes the seed value as the input data to generate a certain set of random numbers. And that's from that certain set of random numbers, certain specific set of random numbers are taken once we call this command. That same specific numbers are taken if we keep the seed value same. The same specific numbers are taken each time once we call the same command, right? So basically that is something that you need to know regarding the random number generation. And in MATLAB, you need to define this seed value in the random number generation procedure to obtain the same values as the output each and every time you call the random function. So is it clear to you? If it is not clear to you, you can mention. Okay, I will go ahead. If you get more questions or difficult sections, you can let me know. Apart from that, like we have something called matrix multiplications. Right, so matrix multiplications is another, section that is of importance, I think, since we are dealing with matrix functions, right? So matrix multiplications can be done in two manners in the MATLAB, and basically there are two manners. One is the normal multiplication, where we do the multiplication, the matrices using the mathematical procedures of multiplying matrices. So there are two types: normal multiplication, where you multiply two matrices, right? Two matrices, let's say A and B, for example, A and B, let's say, and these matrices need to be compatible in order to be multiplied. If you are multiplying A and B matrices, you need to make sure the matrices dimensions are matching to be multiplied. So you can't sometimes multiply two matrices that are not matching in dimension. So if we consider a situation where we have, let's say, A equals to a certain row vector, 1, 2, 3, and B equals to a certain row column vector, 4, 5, 6, and then let's say 8, right? 4, 5, 6, 8. The matrix A is actually 1 by 3. This is 1 by 3. B is 4 by 1. So is it possible for us to do multiplication between these two matrices? Can we do A into B? Can we do multiplication between A and B? Right, so this is basically mathematics. So matrix multiplication should be done only with two matrices whose dimensions match, right? Can we do multiplication between these? No, we can't, right? We can't multiply. So thanks, Irosha. You can't do multiplication between two matrices which are incompatible in the dimensions. So if you try to multiply these two, you will get an error in the MATLAB saying that the dimensions don't match and they are incompatible. We can define these two matrices in the MATLAB environment. We will see how the error comes. So A equals 1, 2, 3. So it is a row vector, and if we want to give two commands in the same line, we have to give the two commands separating using a semicolon. So I want to define A and B. So column vector I can define using this manner, and then semicolon. And then I want to multiply these two, and I will store the values of the multiplication in a variable called D. So I will multiply these. So I will store that in a variable called C. I will store the output in C, right? So if I do like that, I will get an error. I will get an error saying incorrect dimensions for matrix multiplication to check that the number of columns in the first matrix matches the number of rows in the second matrix. Right? So likewise, it will give some error. So in order to avoid that error, we have to check and we have to maintain the compatibility with the dimensions. We have to multiply vectors with which are matching in dimension, and only then we will be able to do the multiplication. So once we do that, we will get a certain output as the answer. Right? If we do the correct multiplication by considering the dimensions of the vectors, then we will be able to obtain a certain output from this command. Right? So that is basically regarding normal multiplication. So this is something that I think you are familiar with. So you can try out with other different types of matrices and you can see the output. Right? So we can actually do some, maybe some other multiplication using rand function, which by defining rand matrix of 2 by 3, I can multiply that with another rand function, rand matrix, which is 3 by 2, right? So I can multiply these two and I can save the output into Z. So here I'm generating a random matrix, and I'm storing that in X, and I'm generating another random matrix, I'm storing that in Y. Then I'm doing the multiplication between X and Y, and then I'm storing the values of the output in the Z variable. So, we need to check whether these are compatible. So if they are not compatible, I will get an error. Otherwise, I will get an output. The output will be equal to a random function, which is of size 2 by 2. Right? So you can do multiplication like this. Normal multiplication can be done like this, right? And we need to check the dimensions compatibility when you are doing the multiplication. So another type of multiplication that is basically used is the element-wise multiplication. So element-wise multiplication is something that is used for multiplying element by element in the between matrices in the MATLAB. The element-wise multiplication. Element-wise multiplication. It is a type of multiplication that can be done between two matrices that have similar dimensions or compatible dimensions. And so in here, basically, if you have two elements, two matrices, then those matrices either should have the same number of rows and columns, or else they should have compatible, either they should be same or else they should be compatible with the dimensions. The two matrices that are multiplied should be compatible in the dimensions. So what do we mean by the compatible in the dimensions is that each value that you multiply the matrix with should be able to be multiplied singularly with the other element in the the second matrix. So we will see. So let's say I want to multiply a certain vector, which is 1, 2, 3. Let's say 1, 2, 3. I want to multiply it with a column vector which has values 1, 2, 3, 4. Right? If I want to do element-wise multiplication, I can do this without any problem. So the reason is that I can multiply each of these elements with this certain column vector. Each of these elements can be multiplied with this column vector, and I can produce a matrix at the end. Right? So we will see how we can you do the element-wise multiplication in the command window. So the basic difference here is that once you do the element-wise multiplication, you will multiply the other matrix with a dot command in here. Right? So you have a dot operation done before the multiplication or before the star sign. Right? So you will say A dot star B. So in here, when you want to do element-wise multiplication, you will need to do dot star. You need to use dot star to do the element-wise multiplication. So if you, right? So let's say, right? So if we have this first, if we try to do the multiplication with these two matrices A and B, let's say we can do the element-wise multiplication there. Right? Element-wise multiplication I will do. So between A and B, we can do element-wise multiplication. The reason being the same scenario that I mentioned in here, where the A is equal to a certain row vector and B is equal to a certain column vector. And these can be multiplied element-wise, which means that each element in the first vector can be multiplied with the second vector. Each element can be singularly multiplied with the second vector. So element-wise, we can do the multiplication and get the output. Right? So sometimes we might not be able to do element-wise multiplication. So in this case, we might not be able to do the element-wise multiplication. We will see, right? We will see whether we can do multiplication between X and Y in the element-wise multiplication manner. So if I define another variable, let's say X dot star Y, right? So see, it gives me an error, says that arrays have incompatible sizes for this operation, which means that I cannot multiply two vectors, or I mean, in here these are matrices of size 2 into 3, and the other one is 3 into 2. And if that is the case, we cannot multiply element-wise between these two matrices. The reason being that element-wise multiplication cannot happen when the number of rows in here the number of columns in here is different to the number of rows in here, right? So when you're doing element-wise multiplication, we need to visualize the matrix. We need to visualize the dimensions of the matrix when we are doing element-wise multiplication. We don't understand that, we might run into errors in the code, right? So rather than doing multiplication in that manner, if we had done multiplication with another with another matrix of similar size, we'll be able to do element-wise multiplication, and there won't be any error in here, right? So element-wise multiplication requires us to understand the dimensions of the matrices, and if the dimensions of the matrices are not compatible, then we cannot do the multiplication in the element-wise manner. So we might run into errors if we multiply two matrices with incompatible sizes. If we try to do the element-wise multiplication in that scenario. So basically, like, you need to consider the sizes of the matrices and consider the sizes of the matrices to do the element-wise multiplication. Right? So there's a nice explanation about this element-wise multiplication in the MathWorks website as well. So that is something that I will mention to you at the end of today's class, how you can access data and how you can access information from the MathWorks website easily, and how you can understand the resources in there. So basically, all the things that we are learning today, they are, available for, they are already available in online resources that you can refer, and you can refer some examples related to certain functions, certain other commands that we give in here. You can refer to examples that are available in the MathWorks website. So up to that point, we have discussed about the element-wise multiplication, right? So do you have any questions regarding that? Right. So when we discuss about the element-wise operations, there are also other operations such as squaring, division, also available in the MATLAB. So apart from doing multiplication, you can do division in the element-wise manner. You can do squaring in the element-wise manner. So if you have this matrix, you can do element-wise division, element-wise division in this manner. I can divide each element by 2 by giving dot divide operation and divide by 2. Similarly, I can give another command to take the power of each element by 2. Right? Each element's power I can take by giving this command. So I can get the value of the squared value of each of these elements using this function. Right? So maybe if you want, you can check that out as well. You can check that and see whether it's actually the case. So you can observe if I try to multiply the element or square the element of the Z matrix, right? I'll try to square this element of the Z matrix by multiplying it twice, and I get this value as the output. And the same value I got in here, similar value, approximately same value I got in here when I applied the element-wise square function. And that means that each of these elements had been squared individually when I did this operation on this Z matrix. So element-wise operations can be done like that. Right? So now we will actually learn about some special functions that you can use in MATLAB. And I think that these functions are useful for you if you are going to do some computations in your assignments or in your classroom. If you are going to do some computations, you can use MATLAB to compute the value. So for example, if you want to find the exponential value of a certain number, you can find the exponential value by giving the command exponential or exp, and inside brackets you can give the value or the number that you want to find the exponential of. So whatever the value that you will obtain will correspond to the exponential of the value that we have given inside brackets. So since I have given exponential of 8, they have given me a large number. But if I give the exponential value to of maybe certain small number, and I will get a smaller number than before. Right? So in order for me to check whether this is actually the exponential function, I can give the value of the exponential as well. Right? So if I I can exponential value should so at some point it should be equal to 0, equal to 1. So at 0 it should be equal to 1. So exponential of 0, the output is 1. So it shows that the exponential function is defined using this command. And another function that we can do, that we can implement, is the log function, logarithmic function. And we can do that using log, and inside brackets I can give the value that I find the log of. However, in here, if I just put the log function as just without any other additions, if I implement it like this, it will actually give me the natural logarithmic value. It will actually give me the natural logarithmic value. So what I mean is that, right, the log value will be calculated based on the base of E, right? Based on E. I don't know whether I think you have learned about logarithmic functions in your math classes. In there, you learn about the natural logarithmic cases, right? So there are basically, basically most popularly used logarithmic functions in maths. So one thing is the natural logarithmic, which is to the base E, right? So log to the E. So log values to the base E. So that one, you can give the command in MATLAB as log. Inside brackets, you can give something in here. And if you want the log value to the base 10, let's say log value to the base 10, I need to give a different command, which is log 10, and inside brackets I can give the value that I want to compute the log value of. And similarly for log to the base 2, I can give the command as log 2, and inside brackets I can give the value here. So basically, if you use log function without any addition of numbers, it basically gives me the natural logarithmic value of a certain number. Right? Natural logarithmic value. Natural logarithmic value we can get. Right? And in here you can get the logarithmic value to the base 10. And another one is that we can get the values of logarithmic up to the base 2 using this command. So if I try to find the natural logarithmic value of 2.718, right, which is the value which is equal to the number E, or the value which corresponds to E is equal to 2.718. And if I do that, I will be able to see the final output is equal to almost 1, which means that this log value computes the log to the base E. That is why it gives the value as 1 during at that time, at that value, at this 2.718 value, the final output will be 1, mainly because the input is equal to the base value of the logarithm. However, if I give like y equals log 10, it will give me a different value. It will not be 1, it will be something different, which is 2.3 in here. Right? So similarly, if I give something, it will give a different value, which is not equal to 1. However, if we try this out with log to the base 10, then if I give 10 inside, I will get 1 as the output. So log to the base 2, if I give the log value to the base 2, and inside brackets if I give 2, then I will get the output as 1. So when we are defining the log values, we need to define the base properly. We want to get the base to a certain, base value under a certain base. If we want under base 10, we need to define it explicitly. So that is regarding logarithmic values. So there was a question in the chat, I think, about the random number generation and how we can get, why we are always getting fractions when we call the random function. So random function is defined by default as a function that generates us some kind of fractions. However, if you want integers only, you can define the integers using rand_i function, right? You need to give the rand_i function in order to obtain integers as the output of the random matrix or the vector that you define. And so you can get integers. You use the rand_i function. Use just rand, it will give a value between 0 and 1. Right? So the entire definition of the rand_i you can find using this command help rand_i. Right? If you want to know how these random values can be defined in a certain specific manner, you can refer the help of the MATLAB, and you need to refer this information in order to obtain the correct information regarding the function. So when I say rand_i, you need to define, you can define values inside the rand_i function. And if you if you define right, if you define maybe two numbers, it gives me n by n matrix. If I define two values in here, that gives me I mean a matrix of, let's say in here, if you define the n value as a certain number, then it will give me that certain numbers square matrix, and the values of the elements in the matrix will be between 1 to the value that we define in here, right? So what happened when I defined the matrix in here was that when I said rand I 2, 3, it generated me a matrix of 3 by 3. And in here, the values of the elements will be between 1 and 2. Between 1 and 2, the values are inside this matrix. So if you define another value in here, let's say 5 or something, values that are coming in the matrix will be between 1 and 5. And the matrix size will be 3 by 3. Right? So you can generate integer values also for the random using the rand function, but for that you need to use rand I operation, right? So up to now, I think we learned about specific functions. There are other commands that are also useful, and I think we will go through them. Another command that is useful, we will go through that as well, which is ordering of the values, right? So I will clear this up first. If I want to order some data, I want to keep some data in an ordered manner, and I also want to find some values such as minimum value, maximum value, mean value of a certain vector. I can use specific commands in the MATLAB for that. So basically, I will explain first how we can do the sorting of the elements values in a certain vector. If there is a vector which is having 4, 2, 3, 7, let's say, there are 4 elements, and I want to find let's start with the sorting function, right? We will sort this vector, right? If you want to sort this along the so if this is the vector, actually I can basically sort this very easily. However, if it is a matrix, sorting has to be done both in row wise and column wise, right? So if I have a vector like this, I can do the sorting, and sorting can be done in the ascending order. So let's say sort of A, and then I will get the output in a certain order. So most probably the values will be sorted in the ascending order. So we will check that. So O, I can define the row vector as 4237. In order to make the elements separated, you need to keep the space between the certain specific elements. If you want, you can also add a comma in here to give the elements differentiation. So you can sort out this vector, and you can show that in a certain other vector. And so you can basically see that they are sorted in the ascending order. And if I want to find the minimum value of this vector, I can use min function, this mean of G, let's say. I will get 2. And max function also can be used to find the maximum value. mean value can be used, mean function can be used to find the mean of all the values inside this vector. And then if I have a more complex matrix which has multiple rows and multiple columns, then I can sort the matrix using by defining the sorting direction, whether it should be sorted along the column wise or sorted along the row wise. So if I have a vector which is defined like this, 3, 7, and 5, 0, 4, 2. Right, so this matrix looks like this. Right, I have a matrix which is 3, 7, 5, and 0, 4, 2. There are 2 rows and 3 columns. If I want to sort this matrix along the row wise, right? If I want to sort it along the row wise, then I can give a command. Let's say R equals sort T along the row wise. So let's say, yeah. So it is ordering the elements in each row in ascending order in the row wise direction. 3, 5, 7, 0, 2, 4 is coming. So I want to do the opposite, which is ordering the element values in the column wise direction. I can do it as sort inside brackets P, 1, which gives me the values as 0, 3, 4, 7, 2, 5 along the column wise direction. So ascending order can be retained in the column wise direction using this comma P, comma 1, right? Comma 1, comma 1. And then if you do the ordering in the column wise direction. Right, so that is something that again you don't have to remember, but you can refer the resources and you can get understanding regarding that. Right, so there are similar functions to this, similar to the sort function that uses this row wise sorting, row wise size determining functions. That means that if I want to find the size of a matrix in the row wise direction, then I need to use a specific command. If I want to find it in the column wise, I need to use a specific command, and that will be defined using the using similar to the sort function, where we define the row wise and the column wise based on 1 and 2. Right, so row wise ordering we have done using 2, and column wise ordering we have done using 1. So that is regarding sorting. And so in order to understand how these functions work, you will have to refer the documentation regarding the functions of MATLAB. So the easiest one that you can do is go to help, and you can type the function that you want to find some data regarding. That you have some function that you don't know the definition, you can go to help and type the function name. It could be sort, it could be mean, it could be max. Whatever the function that you don't know the explanation of, you can type help and you can type the function name. So if the MATLAB knows the definition, it will give the definition, its details. Also, it will give the examples that helps you to run the code and identify what the command is doing. And this explanation part gives you the definition of the command. So the clear definition of the command can be seen in here, and it will give us how the sort function can be defined. So if you basically define the sort function as it is, it will sort any elements inside there in ascending order. However, if there's a matrix that you want to sort, you can define the specific dimension along which the elements has to be ordered. And the dimension has to be defined as either as 1 or 2. right? And that you need to define specifically using 102. And also this says that there's another method of defining that, that is by defining whether it should be ascending or descending. So you can define whether the ordering has to be done in the ascending order or descending order based on your preference. You can also do that using this manner. So basically what I wanted to tell you was that for most of the functions, all the MATLAB functions, you can find the explanation of that function using once you type help and the function name, right? So that is the easiest manner for you to understand the function and its behavior. Apart from that, there are other methods of accessing the data regarding the function as well. So another method is typing doc, and then typing the certain function name, right? So, and then you will be able to see a certain website uh, popping up, which is the website uh, uh, maintained by the MathWorks, that gives us the definition of the certain command or the function that is available in the MathWorks website. So this doc function gives us this the link to the MathWorks website that has this definition. When you go down, you will be able to see that some examples already over here, right? Some examples that are included here, you can see, which uses that function that we define. So all these examples can be tried out, and you can see all the different ways that certain function can be used. And so it gives most of the different cases that can be considered. Right. So regarding help and regarding doc, that is basically regarding that. So so from MATLAB, you can get a lot of data regarding the functions. Right. So another thing I wanted to mention is that matrix indexing. I think that is one of the most important things about MATLAB. Right. So I have a quiz also that I want to give. However, I think I will discuss this matrix indexing part, and then I will get into the matrix indexing. Sorry, quiz part. So I will first discuss about the indexing. So I will clear this command window. Clear I do by CLC, and once I come to this place, I can define a certain matrix. Let's say 1, 3, 7, and then 4, 10, 3, right? 4, 10, 3. And in here, if I want to obtain some matrix indexes separately, I can right? I can access any value in this matrix using the indexing. Right? Using matrix indexing, I can access any element that I want in the matrix. So if I want to access, let's say, I want to access one certain element in this matrix, what should I give as the command? If I want to access the first element in this matrix, what should I give as the command, as you think? If I want to obtain the very first element. Right? So if I want to get the very first element, I will use A 1, 1, right? So if I do that, I will be able to get the very first element in the matrix. And if I say, if I want to get the last element, I can get, I can actually use different methods to get the last element. But first, I will say that I want the last element by saying that I want the value in the second row in the third column. If I say like that, I will get the number 3, which is in the 2, 3 position. Right? So the matrix indexing is about indexing exactly the element that you want to achieve. Right? So that is how that is happening. And if I want to obtain a certain entire row from the matrix A, then I can say A. If I want to set all the values in the entire row, I need to say that I want all the values of row 1. Let's say I want all the values of row 1, which includes all the values in the columns, I mean, in the row 1. So what I say is that, what I'm saying is that if I want all the values in the first row, I need the values of all the elements that belong to that row, and all the corresponding column values must come. So I will get 1, 3, 7 as the output. If I want the second row, I should say A 2, double colon or colon. Then I will get the second row. Right? So that is how you can obtain certain rows and columns in a matrix. And are you able to tell me how you can access a certain column in the matrix? Let's say I want to obtain all the values in the second column in this matrix that I have defined. Let's say I want all the values in this second column in this matrix A. How can I obtain that? Can you let me know in the chat, or you can let me know? How can I obtain all the values in the second column? Yeah. So I think Sahan has given correct answer, which is obtaining the values of A under all rows and second column. And that will give me the second column values of the matrix A. So 3 and 10, I obtain. Right? So I think by that, you will be able to understand how you can obtain the element values from a certain matrix. Right? So you need to be really good in this matrix indexing in order to filter out the necessary components from a matrix. Right? So if you have a large data set, let's say, or a list of data, and you want only certain specific amount of data from that list or the matrix, you need to use these indexing methods to obtain the certain range of data inside the list or the matrix. Right? So if you are doing machine learning, if you are doing any kind of signal processing, if you are doing any kind of multiplication with between two matrices or between two values, then you need to obtain the necessary data from the large data you have. So if you have large amounts of data, you need to extract out only the important or needed data from the large matrix you have. Right? So that extraction can be done using this matrix indexing. Right? So another has asked about the unsorted matrices and how we can use minimum maximum functions on unsorted matrices. So yeah, we can see that, right? So if we have a certain matrix, let's say B, which I have in an unsorted manner. So I will say it is having elements like this. So I will erase first this command window. I hope you can see the screen. So I define D as a vector which has value 4, 7, 0, 2, and then I will try to find the minimum of the D. Minimum of D I will get, and I will get the value 0. It doesn't really matter whether I sort the matrix or not. Right? I can find the maximum, minimum, those values of the vector without any problem. I don't need to sort them all the time. Right? I can find maximum, minimum, mean value without any problem for any vector or for any vector, you can directly obtain the minimum, maximum values without sorting them out. So that is regarding the matrix indexing, right? So if you have any questions regarding matrix indexing, you can let me know. Apart from that, if you have a random matrix, let's say some kind of random matrix of which you don't know the size of, right? Let's say, you define a certain matrix, you know the size, but in this case, let's assume that you don't have any information about the information included in the matrix, and you want to find the size of this matrix. If you want to find the size of the matrix, you can use the command size, right? Size the certain matrix, right? However, some problem or some confusion is there in here, which is that there are two outputs that are coming as the output. There are two outputs. So what do they mean, right? So mainly the first output gives the amount of rows in the matrix. Second output gives the amount of columns in the matrix. Okay? So in order for us to understand that, we can, or in order to get a clear idea about that, we can define the output of the command size as a vector, which we define as rows and columns. Right? So if we do that, then output of this size function will be stored in rows and columns. Right? And then if we run this, it will basically give the rows as 2 and columns as 3. Since we know that the first value actually corresponds to the number of rows in the matrix, and the second element actually corresponds to the number of columns in the matrix. So by doing that, by using the size command, you can find the size of a certain matrix. Right? So, yeah. So another thing, I think I will explain to you one more thing before I can move on to the quiz. So in MATLAB, right, you want to define a very large matrix, a large matrix or a large vector. You can do that easily using by defining it as using some columns between the two limits that you want the numbers generated. So you will do that. So if you want a certain large data set, right, between 1 and 10 to the power 5, right? So if I give this, so if I run this, it will give a large data array. Right? We'll have elements up to 100,000. Right? So that can be there. So I will clear this up. PLC. Then, if I want a subset of the vector that I just defined, right? Let's say I define A as 1 into 10 to the 5, right? So this value, so the values of this vector will be between 1 to 10 to the 5. And if I want values, the subset of A, if I want, I can obtain subset of A using a command where we take the values of A and only to take the values in, let's say, in the odd places of the vector. Right? So if I want vector subset of the A vector, and I can obtain that using this command, which says that I'm taking A matrix, and inside brackets I'm taking the values from 1 up to the last point or the last element of the matrix in consideration, and I take values with spacing of 2, which means that I take values of 1, 3, 5, like that, up to the end element. Right? So I can generate a subset of the main matrix using this command. Also, you can notice that I can use the end word to specify the last element possible. If I don't know exactly the last element in this case. Right? So this will generate me a vector with spacing of 2. Okay, so if I run this, I can see that only the subset of data is given to me. So the last element in here is 99,999, which means that the last element has been omitted because only the odd numbers has been taken in here. So the odd numbers have been taken by that command that we just gave. Okay. So when we are handling large data sets, we can take parts of that data set using these kind of indexing and indexing methods. So these kind of indexing methods are useful for us to extract only certain parts of the data that we have. Right? So that is regarding matrix indexing basically. So I think by that point we can maybe try to like end the session regarding the basics of MATLAB, basic commands in MATLAB. And with that, I think I will be able to move on to the quiz. Right? Before moving on to the quiz, I also want to mention one thing about the matrix indexing. Right? Matrix indexing. And so if I try to clear this, if I have a certain matrix, let's say 2 to 3, and if I, for example, if I try to index the 0th element, it will give me an error, right? Which means that in MATLAB, we have the indexing starting from 1, which means that there's no 0th element, right? So if you learned Python, I think in the Python, you must have seen that you can access the 0th element of a certain vector or a certain list, let's say list of data or a data set. You can access the 0th element. You can say the 0th element of a matrix. But in here, you can't say 0th element. The element should start with 1, which means that the indexing starts with 1, 2, likewise. Right? So the element indexing starts from 1. So if you say that this is, so if this is a matrix, I need to define 2 places. Even if I define 2 places with zeros, I will get the error. So which means that I can't do 0 indexing. 0 indexing cannot be done. 0 cannot be an index in the MATLAB indexing. You need to start with 1. Starting index will be always 1. Right? So that is basically regarding indexing. So shall we move on to the quiz? So is it okay if I take maybe 5 more minutes? right? I hope it is okay. So I will share my screen. So this is a fun game, fun quiz. So you can go to the link that I share. I will share a link in the chat. So you can go to this link. So please join the quiz. And you can mention your group number, group A, B, something like that, and your name, right? When you're joining. Okay. So please mention your group number, otherwise I might not be able to give marks to your group. Okay. I think only 20 students can join this quiz, right? So only the first 20 can join. Okay. So it's like it's that version. So I think there's no option. I would have to go with this, right? And others will have to watch. So I'm sorry about that. So I think I will go ahead with this. So I think you need to open. I think I will have to stop this for the moment. Good. Good. It says that I have reached the user limit. don't know why it stopped. I think 50 people can join for the session. Okay, I think only 10. No, not 8 because normally I use it for more than 10 people. So anyway, I think I will share the link again. I think only 10 people can join if it is okay with you. So I will share the link with you again, and only 10 people can join. So I believe it is the case if that if you can please join as soon as possible. Only 10 people can join this. So I think that's enough. There's one more. Okay, I think no problem so far. Okay, I think we'll start. Right. So yeah, more than 20% people I cannot have. So right. So I think even if I start going ahead, I cannot show the questions properly without that. So is it how many groups are there in your system? Like in your grouping, how many groups are there? Are there like 70, 78 groups? Is it like that? Right. I think some of you need to
It's about 80 groups here.
80 groups. I think not all 80 can join this. So it's already getting like if it is above 20, I think they cannot join. So it's possible if one person is there from each team, but even that is not possible, I think, right?
And also there are individual participants as well.
Okay. Okay, so let's not worry about the quiz then. I will not give marks from that to you. So only first 20 can actually join this one. So if possible, if you can, I think, leave, or if you can just maybe remove, or we can maybe we can play and another time, right? So I cannot actually accommodate more than 20. So in here, I think maybe there are 20 people. Yeah. So right. So I think I will have to remove, I think, some students, right? So next time I will again share the link again. I will create another link for this, and then I will create, so the first 20 can join. I'm sorry about it. And then I will not give any marks. You will be able to just see how the quiz goes. Right? Otherwise, I think you cannot view the questions. So I will give the link again in the in this again, right? So last I think people I think I have removed. So and I will lock this. So only this students are going. I will start the quiz. You need to look at the screen. The question is on the screen. You can give the answer from your devices. So what command is used to clear the command window in MATLAB? Yes. So a lot of you got the correct answer. CLC is the command used to clear the command window contents. If you use the clear command, it will clear the values of the variables that are stored in the MATLAB workspace. Values of the variables will be cleared once you give the clear command. And if you use other commands, they're actually used for other purposes, close and reset. Reset is not a command that is used by default in MATLAB. Close is a command used, and it is used basically to close the like windows open in the MATLAB. So I think this is the scoreboard. So 957, group number 4 has the lead. I will not give marks on this. So for element-wise multiplication, sizes of A and B must be the same or compatible. This is true or false. Okay, so most of you got the correct answer. So element-wise multiplication, when you're doing that, you need to first consider whether they are of same size. If they're in the same size, you can do element-wise multiplication without any problem. Each element will be multiplied with the corresponding element in the other matrix. However, if they are different in size, you need to check whether they are compatible. If they are compatible, you can do element-wise multiplication, and in that element-wise multiplication, you will get a resultant matrix which is different in dimension to the initial dimensions of the matrices we use for the multiplication. And okay, so this is the score. In MATLAB, indexing starts from 0. Is this correct or false? This is false, right? So many of you got the correct answer. The indexing starts from 1. In MATLAB, indexing starts from 1. In other programming languages, most of the time, indexing starts from 0. In most of the programming languages that you have, indexing starts from 0. But in MATLAB, indexing starts from 1. So the scoreboard looks like this. So how do you comment a single line in MATLAB? I think I did not discuss about the commenting properly, but hope you can give the correct answer in either way possible. Okay, so commenting can be done using the percentage mark. The percentage mark is the one used for commenting in MATLAB. In other languages, you use double slash, right? In Python, for example, you use double slash commenting. And this hash mark is used for commenting in like languages such as C, according to my knowledge. So there are different methods of commenting. In MATLAB, we use the percentage mark, the correct one. So I think many of you got the correct answer here. So what is the command to display the contents of a variable? When I think I didn't discuss that explicitly in this class. But yeah, there's a function called display that you can use to display the values of a certain variable. And you can define that inside brackets in the display function. So yeah, the next question, what does MATLAB stand for? Yes, matrix laboratory. Many of you got the first now. Okay, so I think 04 is still in the lead. So what is the default extension for MATLAB script files? So what is the extension that is used to identify MATLAB files? Okay, so .m type is the one which we use by default to save code files of MATLAB. Now, other ones such as .mat, it is used to store a matrix file with the values of the matrix. If it is .text, it is like a notepad, format, right? So .text, .py is the Python files. So the correct answer is .m. Which command displays the path to current working directory in MATLAB? So, so right. So the a specific command that you can use to find the current working directory in MATLAB. So I believe I can go and show that. If you type pwd in this, you will be able to see the directory and the path to the current file that I'm working in. So, so this is actually giving us the path to working directory, right? Path to working directory is given by pwd, gives us the direction or the path to the current directory that we are working in. Right. So earlier questions that we had regarding display function is basically used to display any kind of variable that we defined. Let's say display or variable A, and it will display the variable A. So display is the function that we use to display certain value of a certain variable. Okay, so we will move on to the next question. Which function is used to generate a matrix with random values between 0 and 1? Yeah, so first one is the correct answer. I think a lot of you got the correct answer. Right, we discussed about the rand function a lot, and it gives the values between 0 and 1. And based on the dimension that you define, it gives a dimension, it gives a matrix of that dimension. And each value in that matrix will have a value between 0 and 1. Okay, so 04 is still in the lead. We can go ahead. Which MATLAB function is used to create an identity matrix? Here the first one is the correct answer. Identity matrix are generated using I function. So we will go ahead. So what is the operator for matrix multiplication? Okay, so I think all of you got the correct answer, which is the star sign. So I think with that we end the quiz. And 04 is in the lead. So I think that's great. So the last, sorry, there's another question, sorry. Yeah, so the number of columns in the first matrix must be equal to the number of rows in the second matrix for certain matrix multiplication to happen. In here, we are not specifying the element-wise matrix multiplication. So this means the normal matrix multiplication. So most of you got the correct answer. So mathematically, this is the correct answer, which will have to the matrix multiplication. So I think with that, I think we end the quiz. So these are the winners of the quiz. So I think I was not able to join all of you to the quiz, and therefore I think I will not add this mark to your final mark. So since we are only able to join about 20 people in here. So I think with that, I think I would like to end today's session. So if you have any questions, you can ask, and I will resolve your questions.
Thank you, madam, for sharing your knowledge and make the session much more valuable. Madam, we are ready with a small token of appreciation. Please accept this with our most heartfelt gratitude.
Thank you so much.
It's time to you to clarify your doubts. If you have any question directed to madam, please use the raise hand option and we'll give you a chance to unmute one by one. We have 5 minutes to clarify your subject related matters. Your times start now. If you have any question, you can raise hand or also you can use the chat box to drop your questions.
So is there a way to download Mac OS or the Mac OS? So with the current installation link, are you not able to download? I think for the okay. So I will search about that and I will get back to you by maybe tomorrow, or I mean the next session. I will get back to you on that. I think operating systems might not be a problem. I think even for macOS it must be possible, but I don't know this version is available. The latest version is available for the macOS. That I need to figure out.
It seems like questions are over. Once again, thank you, madam, for your great support. There is a kind reminder. We are having our third session on 20th December at 7 p.m. Hope you'll join the session. Before conclude the session, we request all of you to switch on your cameras to take group photo. You can use the virtual background you drop in the chat box. We'll give you 2 minutes to get ready and then let's take the photograph. Thank you, everyone. Now it's time to conclude the today's session. Thank you, everyone, for joining us. Wishing you a journey. Wish you a success on journey ahead. Have a nice day. I am Imalka Sandarayano, signing off as the moderator. Thank you.